Hello students, welcome to Chori Maths. Now let's solve this question. Look at it displayed on the screen. So the first thing I need to do in this case is to have it as 2x all squared all over x minus 2 all squared. It's a very valid process. Then this is plus x squared is equals to 12. Very important step. Now having this, I can now expand this the numerator actually, so that I'm gonna have 4x squared. This will now be over. This is what I have. Okay, then plus x squared is equals to 12. Now looking at it very well, you could see that it is a case of a fraction on the left hand side. So I'm gonna make it to be a single fraction with single denominator. So the LCM, of course, this is like over 1. So just take note. So the LCM is going to be x minus 2 all squared. Now this is going to be 4x squared plus. Here I'm going to have x squared into x minus 2 all squared. Now this is equals to 12. All right. Take it to heart. Make sure you understand very well. Now, I'm going to expand further. So this 4x squared plus I have x squared. Now check this out. Expanding what is in the bracket, that is x minus 2 all squared. I'm going to have x squared minus 4x then plus 4. Okay, so I've expanded the bracket in that side. Then this is all over x minus 2 all squared equals to 12. Now working it further, I'm going to have 4x squared plus x raised to power 4 minus 4x cubed, then plus 4x squared down. Okay, this is x minus 2 all squared is equals to 12. Looking at it very well, I can bring x raised to power 4 first. Then I will rearrange to have 4x cubed, then plus 8x squared. Now I actually added these two. All right. This will now be all over x minus 2 all squared is equals to 12. Now, since I've progressed to this stage, remember, if I have a plus b all over 2, I can write it as a over 2 plus b over 2, right? So with that knowledge, I'm going to have it as x raised to power 4 over x minus 2 all squared. Then minus, I have 4x cubed plus 8x squared all over x minus 2 all squared. Now, I need you to pay attention to what I'm doing. Now, I'm going somewhere. If you check this, I can actually work it out. I factorize it, okay? And that is why I'm going the way I'm going, so that I'm going to have x raised to power 4 all over x minus 2 all squared minus, now bringing out 4x squared, I'm going to have x minus 2 in bracket. Okay, then if I wish, I can have this as x minus 2 into x minus 2. Why I'm doing this is because I want to open it so that you see how I'm going to cancel it. Now can you see that these two cancel themselves out? So I don't have any issue with that. This is x raised to power 4 all over x minus 2 all squared minus 4x squared all over x minus 2. And this is equals to 12. Now looking at it, you could see that I can have x raised to power 4 all over x minus 2 all squared minus, what about if I have 4 into x squared over x minus 2? Is there any problem with that? No, it is very correct. But again, look at this. I can work it out. And what will I do? I want you to have this understanding. If for any reason I have x, or let me put it this way, one of the laws of indices, if I have x raised to power n and this is raised to power m, is going to be x raised to power n times m. That is very important and very valid. And I want you to know that if I have x over y all raised to power n is the same thing as having x raised to power n over y raised to power n. So it goes vice versa, okay? Those are the two things I'm going to use to analyze this question. Now I'm going to have x raised to power 2 all squared all over x minus 2 all squared, then minus 4 into x squared over x minus 2, okay, equals to 12. Now looking at it very well, you could see that I can have this one, I can have this as x squared over x minus 2 all squared. Now I got it from this, okay, so take note. Now minus, we have 4 into x squared all over x minus 2 is equals to 12. Now I have made it so simplified that I can substitute to say let y be equals to x squared over x minus 2. Now having said that, then I'm going to have y squared minus 4y is equals to 12, which will be y squared minus 4y minus 12 is equals to 0. Now this is a very factorizable quadratic equation that the method is to multiply these two n terms, what I'm going to have minus 12y squared. Then the needed factors in this case will be minus 6y and plus 2y. Okay, substituting to actually work out this quadratic equation, I'm going to have y squared minus 6y then plus 2y minus 12 is equals to 0. So that I have y into y minus 6 then plus 2 into y minus 6 is equals to 0. So y minus 6 into y plus 2 is equals to 0. Now having this will now confirm to us that it's either y minus 6 is equals to 0, which implies that y is equals to 6, or y plus 2 is equals to 0, which implies that y is equals to minus 2. But you see, this is not what we want. We want x, okay? I introduce y. So what I'm going to do is to recall the fact that we said let y be equals to x squared over x minus 2. So therefore, when y is equals to 6, I'm going to have 6 is equals to x squared all over x minus 2. Now this is going to be x squared, okay, is equals to 6 into x minus 2. So that I'll have x squared is equals to 6x minus 12. Now this x squared minus 6x plus 12 is equals to 0. Now this is not factorizable, so we are going to make use of a quadratic equation which says x is going to be minus b plus minus root of b squared minus 4ac all over 2a. Now, what do we do with this? How do I get my ABC? Recall that if the equation is x squared minus 6x plus 12 is equals to 0, general equation of a circle is ax squared plus bx plus c is equals to 0. Now, having this and comparing coefficients, you can find out that a is equals to 1, b is equals to minus 6, and c is equals to 12. So substituting in the bracket, in the formula, I'm going to have x equals to minus, then we have minus 6, okay, then plus minus root of 6 minus 6 squared. All right, minus 4 into a is 1, then we have 12, okay, and this will be all over 2 into 1. Now x will then be 6 plus minus root of, we have 36, okay, minus that should be 48, all right, all over 2. Now x is equals to 6 plus minus root of minus 12, okay, all over 2. Now this will be x is equals to 6 plus minus. Now take note of this. This will be 12. I can write it like this, okay, then times root of minus 1 all over 2. Now this is x is equals to 6 plus minus root of 12. Writing it in short form should be 2 root 3, okay. Then root of negative 1 is a complex number which is equals to I, right? So I'm going to have I, okay, all over 2. So I can factorize 2 out, so that I'm going to have 2 into, we have 3 plus minus root of 3i all over 2. This cancels this out. So my x is 3 plus minus root of 3i. Now in this case, we can say x1 will be 3 plus root of 3i. Then x2 will be 3 minus root of 3 I. Good. Okay, but that is not the end. Remember, we still have another possibility. Now, what about when we have y is equals to minus 2? So I'm going to have minus 2 is equals to x squared all over x minus 2. When we cross multiply, we have x squared is equals to is equals to 2 minus 2 into x minus 2. Now x squared will now be equals to minus 2x plus 4. Bringing it together, we have x squared minus or plus 2x now, then minus 4 is equals to 0. Yet not factorizable. So we can use the formula. X now will now be equals to, just as we did in the first case, this minus b is 2. So we have it this way. Then plus minus root of, we have 2 all squared, then minus 4 into a, which is 1, then into minus 4, right? So this is what we have. Okay, so this is all over 2. Now we have x will now be equals to minus 2 plus minus root of, we have 4, then this is plus 16 all over 2. So we have x is equals to minus 2 plus minus root of 20 all over 2. X will now be minus 2 plus minus, that should be 2 root 5, all right? I think I'm correct. Yes, I'm very correct. Then all over 2. Then I can factorize 2 out, so that I'm going to have 2 into minus 1 plus minus root of 5, cover the bracket, all over 2. So this cancels this out. At the end of the day, my x will be minus 1 plus minus root of 5. So that we can say x, remember, let me check. Okay, I have x1. So this should be x3 will now be equals to 1 minus 1 plus root of 5. Then x4 will be 1 plus, sorry, 1, not 1 plus, should be minus 1 minus root of 5. These are the 4 that I have. Check them out. We have 1, 2, 3, 4. So these are the 4 roots or solutions to this particular problem. Now listen, I want to believe you enjoyed the video. It's lengthy, but it's enjoyable. So please do not forget to subscribe to my videos, to my channel, for more interesting videos and very educative videos. Thank you so much.